consider the given quadratic equation in standard form. We now want to write the function in its vertex form, and then use the vertex form to identify the coordinates of the vertex for this parabola. So we are given a quadratic equation in standard form, f of x is equal to 3x squared minus 6x plus 1. Now, let's recall that in order to rewrite a quadratic equation in standard form to its corresponding vertex form, we need to complete the square on the first two terms. Now, completing the square requires a leading coefficient of 1. So that's where we're going to begin. The first thing that we want to do here is factor out the leading coefficient of the x squared term from the first two terms containing x. So in other words, we are going to rewrite f of x as 3 multiplied by x squared minus 2x in parentheses plus 1. So now that we have factored out the leading coefficient of the x squared terms from the first two terms, we are officially ready to complete the square on the terms within the parentheses. So in other words, within those parentheses, we are going to add and subtract half of the coefficient attached to x. So in other words, we are adding and subtracting negative 2 divided by 2 squared. And we can now simplify. So we can rewrite this as 3 multiplied by x squared minus 2x, and this will be plus negative 1 squared minus negative 1 squared, and that's all within parentheses, and we have this plus 1 on the outside. So rewriting this again, simplifying further, we have 3 multiplied by x squared minus 2x plus 1 minus 1, and then again plus 1 on the outside of our parentheses. Now notice we officially have obtained the perfect square trinomial within those, or with those first 3 terms. So we can now rewrite this further as 3 multiplied as x minus 1 squared minus 1, and then outside of the parentheses we have plus 1. And last but not least, to obtain the vertex form, we now need to distribute the 3 on the outside of the parentheses through to each term within those parentheses, which leaves us with 3 times this binomial product, x minus 1 squared minus 3 plus 1, and combining up those two constant terms, we are left with the vertex form, 3 times x minus 1 squared minus 2. So this is the vertex form of our quadratic equation, and using this form, we can see the coordinates of the vertex in this case are the ordered pairs 1, negative 2. Making this our beautiful final answer.